Hi students, welcome to this video session. My name is Samuel Chukwuemeka, aka Samdon for Peace. In this video session we shall solve a 2x2 linear systems using the Gaussian elimination method. The Gaussian elimination method is also referred to as the Gauss-Jordan method. It was a method developed by Carl Gauss and Wilhelm Jordan. So some textbooks will refer to it as the Gauss-Jordan elimination method or the Gauss-Jordan method. Some textbooks will also refer to it as the row reduction method. So some of you might ask me, but you have done this video before, right? Yeah, I did this video some years ago. It's just that I removed it, so I am doing an updated one. So don't be surprised. This is part 1 of the video. We shall solve 2x2 linear systems, those ones you see on my left. In the part 2 of the video we shall do solution of 3x3 linear systems using the Gauss-Jordan method. Now first of all, let's look at the steps. Before you even talk about using this method, it's important that you view the video on a augmented matrix, row echelon matrix, and reduced row echelon matrix. That video is important that you view it. It's very important you view it. But we shall go over the basics in this video as well. Now, let's first of all look at the steps you need to take before you even talk about using this method. The steps to take, before we look at the process. Yeah, steps in using the Gauss-Jordan method, or the Gaussian elimination method, or the row reduction method. So first of all, first step, you want to make sure that the variables are complete. You want to make sure that the variables are complete. Okay, and in this video we shall limit it to square matrices. We're going to limit it to square matrices that are consistent, that have consistent solution, that's consistent systems, okay, which have distinct solutions. We shall limit it to that. So you want to make sure that the variables are complete. Okay, x, y, y. Now if you look at the question 4, on the second equation, question 4, you see that the x is missing. So if you see any variable missing, you have to complete that variable by assigning a 0 coefficient. Okay, so you want to make sure the variables are complete. Variables are complete. Okay, if they are not complete, you have to complete it. If they are not complete, if they are incomplete, then you have to complete it by assigning them by assigning 0 coefficients. By assigning 0 coefficients. And you can be writing this down, okay? Number 2, you want to make sure that the variables are aligned. Okay, make sure the variables are aligned. X, X, Y, Y, constant, constant. Make sure the variables are aligned. If you look at the question 2, you see that they are not aligned. You need to align it. X, X, Y, Y, result, result, constant, constant. Okay? Make sure the variables, okay, and the constants are aligned. And the constants are aligned. Yeah, so in question 2, you see that they are not aligned. You have to align it. You have to align them. Number 3, you want to make sure that if you can simplify it, and number 3 is not really a necessary step, but if you don't like working with big numbers like I do, I don't like working with big numbers. If I can simplify it, I do. I simplify it right away. So if you can simplify any equation, do so. Okay, simplify any equation as possible. Okay. If you look at question 3, equation 2, question 3 in equation 2, you can simplify it by dividing both sides by 2. Provided that whatever you do to the left-hand side, you have to do to the right-hand side, because this is an equation. Okay, if you simplify it, it will work. It will still work. So simplify any equations as necessary or as possible. Okay, to simplify any equation as necessary or as possible. Then number 4, the next thing you want to do is you want to now write the linear system as an augmented matrix. You want to write the linear system as an augmented matrix. Okay? Write the linear system as an augmented matrix. Okay? And once you have done that, you now want to apply the row reduction method, okay, or the Gauss-Jordan method. You now want to apply that, you have to apply row reduction to reduce it to a reduced row echelon matrix. Okay? Now use the Gauss-Jordan method to reduce the matrix, to convert it, to reduce the matrix to a reduced row echelon matrix. Okay? And once you have done it, number 6, you now solve and check. Solve and check. Solve and check your solutions. Solve and check your solutions. Solve the problem. Of course, when you're doing that, you have solved it, and then you check your solutions. So these are the kind of steps you need. This is just the steps in using the Gauss-Jordan method. We still have to list some steps. Okay, the Gaussian elimination method process. Okay, the row reduction process. Row reduction process. How do we convert the matrix to a reduced row echelon form. And we have kind of discussed this initially, but we shall still talk about it. We shall still have a refresher in this video. So let's get started. Yeah, I will have to erase this so that I'll have space. Question 1, we have 3x plus 4y equal to 13. This is equation 1. Then we have 2x minus 3y equal to negative 14. So we look at this, we try to go over the steps. The variables are complete, the variables are aligned, the constants are aligned. And can we simplify it? 3, 4, 13? No. 2, negative 3, negative 14? No, we can't simplify it. So we just go ahead and write it as an augmented matrix. So we write this as an augmented matrix, 3, 2, 4, negative 3. And this is 13, negative 14. The next thing is to reduce it. We have to reduce it to a reduced row echelon matrix. Now, because this is a square matrix, you can also say just convert it to an identity matrix. Okay? Just go ahead and convert it to an identity matrix, because, you know why? Because if we have this 1, 0, 0, 1, this is the identity matrix, and this will be xy. We want to reduce this matrix. This is the matrix of coefficients. This is the matrix of coefficients. And this is the matrix of constants. That is what an augmented matrix is about. So you want to reduce this matrix of coefficients to an identity matrix, which is also a reduced row echelon matrix. And once you reduce it, you can see that whatever is remaining here, the first one will be x and the second one will be y. That is it. Now, how do you reduce it now? You have to apply row operations. And let me repeat, now, some textbooks have it differently. I am using my own rules, and my rules work. And if you can understand my rules, you will not have problem with any matrix. You will not. Trust me, you will not. So, I'm not, your textbooks might write a different thing, and it might be confusing. Trust me. If you learn these rules, you will not have problems. So, we are going to apply row operations. And we look at this, okay? So you have a row, in this case we have 2 rows, row 1 and row 2. Okay, this is row 1 and this is row 2. You have 2 rows, this is arrow 1 here, and this is arrow 2 here. Those are the 2 rows you have. Arrow 1 and arrow 2. Now, imagine, just take it that a doctor is operating on a patient. So you're going to use one row to operate on another row, or to work on another row. You're using a row to work on another row. Okay? The row that you're using to work on another row, that row should always be on the left hand side. Then the row that you are working on, should be on the right hand side. A row used to work on another row. Okay, let's say, for example, the doctor is operating on a patient. The doctor is operating on the patient. Okay, in this case, doctor operating on a patient. Doctor operating on a patient. So that row should be, the row that used to work on another row should be on the left hand side. Should be on the left hand side. Okay? That's one. And then the row that is being operated on, being worked on, the row that is being worked on, the patient should always be on the right hand side. I'm gonna write it, I'm gonna draw another thing here. 2, row that is being worked on. Being worked on. In this case, the patient should always be on the right hand side. Should always be on the right hand side. On the right hand side. Okay? That's the first two things you need to know. Now, number 3. Okay, in this case, a doctor operating on a patient, Now, the row that is used to work on another row, if a doctor operates on a patient, does the doctor change? No, it does not change. Okay? It does not change. The doctor operating on the patient does not change. So, this row does not change. Row does not change. Okay? And you have to write it first. Write it first. You will see what I mean by write it first. The doctor is operating on the patient. The doctor does not change. It is the patient that changes. The patient that is being operated on changes. So the row that is being worked on the patient should always be on the right hand side. The row changes. Row changes. Okay? Write it after the, write it second. Write it second. And we will see what I mean by writing it first and writing it second. I will show you. Now, third rule. Avoid writing minus in the middle. Okay? Do not write minus in the middle. Use only plus in the middle. Do not use minus sign in the middle or in the operation, okay? Or in the operation, use only addition. Use only addition signs. Use only addition signs. I'll show you in the middle. In the middle. I will show you what I mean. I'm going to show you what I mean by number 3. I'll show you. Number 4. First of all, fix the zeros first. You have to fix these zeros first. Forget about the ones. Now, I've seen some textbooks, they'll try to make ones. No. No. Fix the zeros first before you now get to the ones. Okay? Handle the zeros first. You will make sure that you make this 2 to be 0 first. Don't try to make 3 to be 1 by coming to the value of 1 by 3. Don't do that. Use the zeros first. If you follow my rules, you will not have any problem. You will not. Now, part of my research area is in linear algebra, and I've been teaching this course. Okay? So, make the zeros first before you handle the ones. Okay? Make this 0 first. So, handle the zeros first. Handle the zeros first before the ones. Before the ones. Okay? Alright? And then as we are moving on, there's another trick I will show you as we are moving on. Okay, let's start. So what do we want to do? What do we want to do now? What do we want to do in this row operation first? This is row operations. Row operations. That's what we are using now. The row reduction process. Okay? Row operations. You can say row operations. We are operating on rows. Row operations. So we will want to make this, remember we are trying to make this matrix of coefficients to an identity matrix or a reduced row echelon form matrix. Okay, and once we do that, whatever is remaining here will be our x and our y. Okay, so you want to use 3 to operate on row 2. You want to use 3 to operate on row 2 because you have to fix the zeros first. Make the zeros first. Okay? Make this 2 to be 0. And how are you going to make 2 to be 0? Are you going to use A to do that? No. You will have to use a doctor to do that. And the doctor right now is the R1, row 1. So, and we don't want minus in the middle. So, and then you're using R1 to operate on R2. So R1 should be on the left hand side, and you don't want minus in the middle, so you put plus. Then R2 should be on the right hand side. Okay? You're using R1 to work on R2. So R1 should be on the left hand side and R2 should be on the right hand side. Always. Avoid confusion. And then you don't want minus to be in the middle. You want the operations to all be positive operations. So you put plus. Now how are you going to do that? Look up. You have 3 and you have 2. How are you going to make this 2 to be 0? And this is R1, this is R2. So what you have to do is you multiply this by 3 and you multiply this by -2. Remember, we don't want negative to be in the middle, no. Instead of saying minus 5 minus 2, rather than saying 5 minus 2, we will prefer to say minus 2 plus 5. We don't want minus to be in the middle. Take note of that. We don't want minus to be in the middle. Instead of saying 5 minus 2, we will prefer to say minus 2 plus 5. Just take note of that. You will not run into confusion if you understand these rules. You will not. You will not run into confusion if you understand these rules. So, what you have to do is, now there's a trick I want to show you. If you have plus plus, okay, or minus minus, as you have it, then you have to multiply the left hand side by a negative number. Just know that. So this will now be -6, and this will be 6, and then you can now add. So what we will do is we will do minus 2 times row 1 plus 3 times row 2. And whatever you write, check it first. Whatever you write, check it first before you continue. Minus 2 times 3 is minus 6. Plus 3 times 2 is 6. Minus 6 plus 6 is 0. So whatever you write, check it first. Check it first to make sure it works before you continue. If you have plus plus or minus minus, okay, then you will have to multiply the left hand side by a negative number. But if you have plus minus or minus plus, you will multiply it by a positive number. Now, as you solve more problems, you will get this. Okay? As you solve more problems, you will get it. Mathematics, practice makes perfect. Practice makes perfect. Okay, so this is our operation. We write it. Then, remember, the row that is used to operate on another row, to work on another row, it does not change. And you write it first. Okay, what is the row that does not change? Row 1. Write it first. 3, 4, 13. Write it first. To avoid confusion, write it first. To avoid confusion, write it first. Then, let's now write the row that changes. Row 2 changes. Minus 2 times 3 is minus 6. And if you want if you're not very good at mental math, or if you want to be extra careful, okay, if you want to be extra careful, or if you're not very good at mental math, you can just write a rough work. You can write your rough work. You can just draw a column and write rough work. Okay, I'm rewriting it minus 2 times 3 plus 3 times 2. Okay, so this gives you minus 6 plus 6, which is 0. You write 0 here. If you don't want to make mistakes, or if you want to be extra careful, you can also do minus 2 times 4, minus 2 times 4 plus 3 times minus 3. Right? So this is minus 8 plus minus 9. Minus 8 plus minus 9, which is what? Minus 17. Minus 17. So you can do that, okay? Minus 2 times 13 is minus 26. Minus 26 minus 42. Okay? Minus 2 times 13 minus 26 plus 3 times minus 14 is minus 42, which is what? Minus what? Minus 68. Are you with me? Minus 68. Okay, then you now come, you have succeeded. You have succeeded in making this to be 0. Who do you need to make to be 0 again? Because like I said, handle the zeros first. Handle the zeros first. Forget about the ones now. Handle the zeros first. So the next guy you need to make to be 0 is this 4. So you're going to, and this 4 is in row 1. And you're going to use row 2 to operate on row 1. Okay, you're going to use row 2 to operate on row 1. So can you give me the operation? Can you give me the row operation that will work? You're using row 2, so write arrow 2, it should be on the left hand side, and plus will always be in the middle, and you're using it to operate on row 1. Alright. So can you, now, in the case whereby, you know, you have 4 and you have minus 17. So 1 is plus and 1 is minus. Or 1 is minus and 1 is plus. Right? You don't need to multiply by, a negative number. You can do this is just times 17 and this is times 4. So this is 68 and this is 68. Minus 68. And you just add. See that? Just add. So this will be, you now do 17 arrow 2 plus what? 4 arrow 1, because this is your arrow 1 and this is your arrow 2. I'm sorry, this is your, yeah, this is your arrow 1, this is your arrow 2. So you have 4 arrow 2, 4 arrow 2 plus 17 arrow 1. And guess what? You need to do what? Check. You need to test it, you need to test it. Anyone you write, you need to what? Test it. 4 times negative 17 is negative 68. Plus 17 times 4 is 68. That's it. Now let me advise you on something. If you're doing what I just did now, it's good to kind of write arrow 2 first and then arrow 1. If you're doing it that way, okay, to avoid confusion, because this is negative 17 and this is 4. And then you just multiply this by 4, multiply this by 17, and this will be negative 68, and this will be 68, and then you add. So this will be 4 arrow 2 plus 17 arrow 1. And you test it. It is very important you always test it. You test it. Alright, so let's finish this operation up. So once we have this, what do we have? Who does not change? Which row does not change? You write it first. Row 2 does not change. You write it first. This is 0 minus 17 minus 68. Okay? And then 4 times 0 is 0 plus 17 times 3 is 51. Right? 4 times negative 17 is negative 68 plus 17 times 4, 68. Negative 68 plus 68, 0. 4 times negative 68 will give us what? What will it be? 4 times 8 is 32, 3. 4 times 6 is 24 plus 3, 27. Plus 17 times 13 will give us what? 17, 13. This is 51. This is 17. Right? 1, 2, 2. Are you with me? Plus what? 4 times negative 68, negative 272 plus 17 times 13 will be 221. 221. So if you do this now, this will be what? Minus what? This is 1, this is what? 5. Are you with me? Minus 51. Okay? That will be minus 51. So you have succeeded in doing what? You have succeeded in making these zeros. You succeeded in making these zeros. Now handle the ones. Handle zeros first, then do the ones. Okay? So this will now be R1 over 51 divided by 51, and then negative R2 divided by 17. You see that? R1 divided by 51 and negative R2 divided by 17. So when you do that, what do you have now? You have 1, 0, negative 1, 1, 0, negative 1, and then you have 0, 1, 4. See that? 0, 1, 4. So you have made this to look like this. Our x is negative 1 and then our y is 4. So xy is negative 1, 4. That's it. Provided you follow all these rules. Okay? Now, do you stop here? No. No way. You have to do what? Check your work. So let's check this. Check. And of course, to check with the main equation, we have 3x plus 4y equal to 13. Let's check, and we have to check for the two equations. We have to check for the two equations. So this is left-hand side, right-hand side. Left-hand side, right-hand side is 13. Left-hand side is 3x plus 4y. Now we have that our x is negative 1. So 3 times negative 1 plus 4 times 4. So this is negative 3 plus 16, and that is 13. Okay? So you dance a little, don't dance too much. You know, you just dance a little, you know, because you got just one equation right. You have to check for the second equation. Second equation, we have 2x minus 3y equal to minus 14. Left-hand side, right-hand side. Left-hand side is 2x minus 3y. Right-hand side is minus 14. So this is 2 times negative 1 minus 3 times 4, which is negative 2 minus 12, which is negative 14. Negative 14 on the left, negative 14 on the right. You can now dance. Okay? Alright. Okay, let's do question 2. Question 2, we have 4x plus y equal to negative 2. 3y equal to 2x plus 8. Now if you look at this, now, the variables are complete, but they are not aligned. You've got to align it. Okay? We've got to align it, and if we do that, what do we have? We have 4x plus y equal to negative 2. Then, if we bring this over, this will be minus 2x plus 3y equal to 8. Now it is aligned. Okay? So it's aligned. We see whether we can simplify it. You know, I don't like working with big numbers. So let's see whether we can simplify it. 4, 1, negative 2 for equation 1. No, we cannot. Negative 2, 3, 8. No, we cannot. Okay, the next thing, we write it as an augmented matrix. This will be 4, negative 2, 1, 3. 4, negative 2, 1, 3. And then negative 2, 8. Alright, let's apply our operations. The first one, we use the first one to operate on the second one. So R1 plus R2, we write it first. Now look at what we have here, 4 and negative 2. You know, this is R1 and this is R2. Okay, some people will come. Now if you look at this, I mean, I know this is plus minus. Some people will come and say multiply this by 2 and then multiply this by 4. Come on now. You can do that, but unless you like big numbers, why don't you just simplify your life? Okay, do it the way you want anyway. Now, because that you look at 2 is a factor of 4. 4 is a multiple of 2. 2 is a factor of 4. 4 is a multiple of 2. I only do this times what? Times 2. Period. And then I have now 4, and then I have this negative 4, and then I can add. That's all I do. So, but what you now need to do is just do R1 plus what? 2R2. 2 times R2. And you do what? You test it. Test it before you move on. So 4 plus 2 times negative 2 is what? 4 plus minus 4, which is 0. So it works. So this will now be what? What would this be? Which row does not change? Row 1. Write it first. So this will be 4, 1, negative 2. We write it first, the row that does not change. Then 4 plus negative 4 is 0. 1 plus 6 is 7. Negative 2 plus 16. Negative 2 plus 16 is 14. Okay? Now what's the next operation? The next operation, we need to make this to be what? 0. But we are using row 2 to operate on what? Row 1. Right? We are using row 2 to operate on row 1. So row 2 will not change. So this is 7 and this is 1. So what will it be? This will be negative R2 plus 7 R1. Because this is negative 7 plus 7 times 1. 7. So negative 7 plus 7 is 0. Negative 7 plus 7. That's it. Some people will write negative 1 R2. That's fine. I just want to write negative R2. If you want to write negative 1 R2, that is fine. Okay? It is fine. Let's complete this stuff. What do we have left? We have a what does not change? What does not change? Row 2. We write it first. 0, 7, 14. Then we have a negative 0 plus 7 times 4 is 28. Then negative 7 plus 7 is 0. Negative 14 minus 14 or negative 14 plus 7 times negative 2 is negative 14. Negative 14 is negative 28. Okay? Then we can deal with the ones now. Okay? This will now give us what? R1 divided by 28 and then R2 divided by 7. And what we got? We have 1, 0, negative 1. And we have 0, 1, 2. 14 divided by 7 is 2. So that shows us that x, y will be negative 1, 2. X is negative 1 and y is 2. Then we do what? Check our work. So we check. In checking, we check with the main problem. We check with the main equation. We do not, I repeat, we do not check with the modified equation. No. We always check with the main equation. Why? Can you tell me why we check with the main equation? Because the modified equation might be wrong. The modified equation might be wrong. Okay? So we check for the first equation, 4x plus y equal to negative 2. Left hand side, right hand side. Left hand side is 4x plus y. Right hand side is negative 2. Our x is negative 1. 4 times negative 1 plus y is 2. So negative 4 plus 2, that is negative 2. Negative 2 on the left, negative 2 on the right. You just kick with your right leg. Boom. Like you're doing a taekwondo. Then the next one, 3y is equal to, let's check it here. 3y is equal to 2x plus 8. Okay? Left hand side, right hand side. Left hand side is 3y, right hand side is 2x plus 8. Y is 2, 3 times 2, which is 6. X is negative 1, 2 times negative 1 plus 8. Negative 2 plus 8, which is 6. 6 on the right, 6 on the left. You now click with the second one. Boom! Okay, folks, we've done number 2. Let's go to number 3. Question 3, we have 3x minus y is equal to 2. 2x plus 4y is equal to 6. Now let's look at this question. Are the variables complete? Yes, they are complete. X and y are in both equations. Are they aligned? Yes, they are aligned. X, y, constant. Okay? Now, can we simplify any of them? Let's look at them. Equation 1. 3, negative 1, 2. 3, negative 1, 2. We cannot simplify. Equation 2. 2, 4, 6. Yes, we can. Yes, we can. So, let's go ahead and simplify equation 2. You can work equation 2 like that. It does not matter. But I would like to simplify mine because I like working with simple numbers, smaller numbers. So if we do that, we have 3x minus y equal to 2. And I will want to divide both sides by 2. It will work. It is the same thing because, and we are even going to check it. We will check it to know whether we are right. But it is going to work because whatever you do to the left hand side, you do to the right hand side. This is an equation. So it's gonna work. Okay? So if you divide both sides by 2, you now have x plus 2y equal to 3. So I would prefer to use this. I write my augmented matrix. 3, 1, negative 1, 2, 2, 3. Okay? My first operation will be what? What is going to be my first operation? What shall be my first operation? Arrow 1 will work on arrow 2. So I have 3 and 1, right? So this will be negative arrow 1 plus 3 arrow 2. Because it's negative 3, negative 1, you can put 1 here if you want to. If you want to, you put negative 1, that's fine. So negative 3 plus 3 times 1, 3. Negative 3 plus 3 is 0. Okay? Let's erase this to finish this. What do we have from here? We have which row does not change? Row 1. Write it fast. 3, negative 1, 2, right? And then negative 3 plus 3 is 0. Negative 1 is 1. Plus 3 times 2, 6. 1 plus 6 is 7. Negative 2 plus 3 times 3, 9. Negative 2 plus 9 is 7. Okay? Next operation, we use row 2 to operate on row 1. So what we got here, minus plus. So we won't need to put any minus. We will have row 2 plus 7 row 1. Okay, because this is 7 plus 7 times negative 1 is negative 7. So 7 minus 7 is 0. Okay? So what we have now, we will have row 2 will remain unchanged. We write it first, 0, 7, 7. Then 0 plus 7 times 3 is 21. 0 plus 21 is 21. 7 plus negative 7, 0. 7 plus 7 times 2, 14. 7 plus 14 is 21. And then what do we do? R1 over 21 and then R2 over 7. So this gives us what? 1, 0, 1, then 0, 1, 1. Wow, perfect, like 1, 1. So xy will be 1, 1. What do we do next? Check our work. So we check with what? The main equation. And this is the main equation, not this. We check with the main equation. Let's check with the first equation. 3x minus y is 2. Left hand side, right hand side. Left hand side is 3x minus y. Right hand side is 2. So this is 1, 1. 3 times 1 minus 1. 3 minus 1, 2. 2 on the left, 2 on the right. You can drink some water. Not beer, water. Okay, then the second equation, 2x plus 4y equal to 6. Left hand side, right hand side. Right hand side is 6. Left hand side is 2x plus 4y. So this is 2 times 1 plus 4 times 1. This is 2 plus 4, 6. 6 on the left, 6 on the right. Drink some tea. Drink some tea or coffee. Okay, so it worked for the third equation. For the 2 equations. It worked for the 2 equations for question 3. So we move over to what? Last but not the least. Question 4. Question 4, we have x plus 2y equal to negative 1 and then y equal to negative 4. I know you guys, if you're asked to use the Gaussian elimination method to do this, you will just ask yourself, why the trouble, you know? Because you can easily substitute. You already know the value of y, that y is negative 4. So why don't you just substitute it in equation 1 and get your x? Well, your professor says you should use this method. And if you decide to use another method, then you don't get credit for it. You get credit for the answer, you don't get credit for the method. If I ask you to use this method, and you use another method, well, you get credit for the answer, but you don't get credit for the method. Okay? Your professor says use this method. If your professor says use matrix inverse method, you use it. If your professor says use Cramer's rule, you use it. If your professor says use Gaussian elimination method, you use it. Okay? Now, let's look at this. The variables, are they complete? They are not. Equation 1, you have x and y. Equation 2, you have only y. So, if they are not complete, you do what? You complete it by adding 0 coefficients. Okay? So, we're going to add 0x plus y equal to negative 4 so that we can complete it. So, we now have x plus 2y is negative 1. Then 0x plus y equal to negative 4. Right now it is complete. And it is aligned also. Now can you simplify it? Equation 1, 1, 2, negative 1. You cannot simplify it. Equation 2, 0, 1, negative 4. You cannot simplify it. So you go ahead to write it as an augmented matrix. And we now have 1, 0, 2, 1. Negative 1, negative 4. Alright, what is our first operation? Let's kind of write it here. 1, 0, 2, 1. Negative 1, negative 4. Okay, our first operation, we use row 1 to operate on row 2, right? And we look at this already. You ask yourself, wait a minute. We don't really need to use the first operation because it is cut out for us already. You see, it is cut out for us already, 1, 0. So we don't really need to use the first operation. So our work has been cut in half. So we just have to use row 2 to operate on row 1 now. We just have to use row 2 to operate on row 1. And what we got now, this will be negative what? Negative 2 row 2 plus row 1. Let us do what? Test it. Negative 2 times 1 is negative 2. Plus 2 is 0. So that works. So what we got now, what row does not change? Row 2 does not change. Write it out first. 0, 1, negative 4. Now let's do row 1. Negative 2 times 0 is 0. Plus 1 is 1. Negative 2 times 1 is negative 2. Plus 2, 0. Negative 2 times negative 4 is 8. Plus negative 1. 8 minus 1 is what? 7. So we now have that what? xy is 7 and negative 4. Let us do what? Check our work. Check with the what? Main equation. First one, x plus 2y is negative 1. Left hand side, right hand side. So this is x plus 2y. This is negative 1. Our x is 7 plus 2 times negative 4. Okay, so this is 7 minus 8. Plus minus 8 if you want to. Okay, which is 7 minus 8, which is negative 1. Negative 1 on the left, negative 1 on the right. Okay? We begin the let's move so that we can get in shape. Begin let's move. But don't move too fast, just stop. You know, just a little, let's move. So to get in shape, let's move campaign. Okay, then, I am not even being paid by it. I am not even being paid by the Flotus. I am advertising the Let's Move campaign, but I am not being paid by Flotus. Okay, let's check for equation 2. Y equal to negative 4. So we have left hand side, right hand side. This is y and this is negative 4. And y is what? Negative 4. And if you want, you can now jump up and touch yourself. Okay? Hey folks, I hope you understood this. Sit tight. Sit tight. In a few minutes we shall do part 2. Gaussian Elimination method part 2. We shall kind of, you know, it will be on 3x3 matrices. 3x3 linear systems. It will be on 3x3 linear systems. Alright, thank you so much for listening, and you have a good evening.